Here's a beautiful statement from calculus. It claims that a specific area under a sine curve is exactly 1/2. But what does this really mean visually? Let's find out. Before we solve this, let's quickly review what a definite integral actually represents. At its heart, integration is a tool for one primary purpose: finding the area under a curve. This notation is a set of instructions. It tells us to find the area under the function f of x, starting from an x value of a and ending at an x value of b. So let's apply this idea to our specific problem. First, we set up a coordinate plane. Here's the graph of our function. Y equals sine of 2x. It's a wave that oscillates twice as fast as the standard sine curve. Our integral is asking for the area under this curve starting at x equals 0 and ending at x equals pi over 4. The claim is that this shaded area is exactly 1/2. To calculate this area, we need a tool called the antiderivative. It's essentially the reverse of a derivative. We need to find a function whose derivative is sine of 2x. The 2x inside the sine requires a special technique. This technique is called U-Substitution. It's used when you have a function nested inside another, and it works by temporarily simplifying the problem. First, we let the variable u equal the inner part 2x. Then we find the derivative of u with respect to x, which is just 2. To complete our substitution, we need an expression for dx. We can find this by rearranging our derivative. Solving for dx, we find it equals du over 2. Now we have everything we need to substitute. 2x becomes u, and dx becomes du over 2. Our complicated integral now looks much simpler. We can pull the constant factor of 1/2 out in front. The integral of sine is a standard result. The function whose derivative is sine of u is negative cosine of u. Performing the integration gives us this expression. We're not done yet. We must substitute back to our original variable, x. Replacing u with 2x gives our final antiderivative, negative 1/2 cosine of 2x. Now we'll use the fundamental theorem of calculus to find the area. The theorem tells us the area is simply the antiderivative evaluated at the upper bound minus the antiderivative evaluated at the lower bound. So we take our antiderivative and prepare to evaluate it from 0 to pi over 4. We will now plug in pi over 4, then subtract the result of plugging in 0. This gives us the full expression. First, we simplify the terms inside the cosine functions. From the unit circle, we know that cosine of pi over 2 is 0, and cosine of 0 is 1. Substituting these values in gives us this. The first term is 0. Now notice we're subtracting a negative number. This is where errors often creep in. Remember, subtracting the negative is the same as adding a positive. So our expression becomes 0 plus 1/2, which gives us a final result of 1/2. So let's bring it all together. We've proven through calculation that the integral evaluates to 1/2, confirming that the area we saw at the beginning is exactly 1/2 square unit. Thanks for watching. If you found this helpful, consider liking and subscribing for more math explorations.